All right, guys, now we're in lesson 20. All right, we're going to talk about polynomial and rational inequalities. There is a trick to solving something such as this. The trick comes from the knowledge that a polynomial can change signs only at zeros. So between two consecutive zeros, a polynomial must be entirely positive or entirely negative. The zeros of the function are also known as critical or boundary points, which divide the real number line into intervals in which the polynomial has no sign changes. All right, so something that you need to know is that for basic polynomials, like 1, 3, and 4, if it's less than or equal to, it's an and statement. So that means you're going to shade in between. If it's greater than or equal to, it's an or statement. So you're going to have to shade in opposite directions. Now, number 2, we have more than 3 terms. So we're going to have to do a little extra on this. We're going to have to do the rational zero test, or the rational zero theorem that we talked about earlier in a previous lesson, in order to find what all our zeros are. And then we'll have to graph. And because of the extra steps, the graphing is not going to be as straightforward, but we'll talk about that when we get there. Okay, so let's get started. On number 1, we have our basic quadratic function, so we're just going to try to factor this. So we got, let's see, x plus minus 3 and 2 multiplied by 6 and give me -1. And so it's going to be minus 3 and 2. And I set it equal to 0 so that I know that my critical, when I set each of these equal to 0, I get x equals, I get -2 and positive 3 for my critical points. All right, the less than is just telling me about my inequality, but when I find my critical points, I just go ahead and set it equal to it. All right, so I got my graph. All right, I got -2 on one side, 3 on the other, and because it's less than, I'm shading in between. All right, and because it's less than, I use parentheses. All right, so that's my answer on that one. -2, 3, like so. All right. Here on number 2, like I said, we need the rational zero test. So we need everything to the same side. So first of all, that's going to be 3x cubed minus x squared minus 12x plus 4 greater than 0. All right, so from here, my rational zero test says I have factors of 4, so plus or minus 1, plus or minus 2, plus or minus 4, all over factors of 3, so plus or minus 1, plus or minus 3. That's going to give me plus or minus 1, plus or minus 2, plus or minus 4, and then everything over 3, so plus or minus 1/3, plus or minus 2/3, plus or minus 4/3. Now, do you need all of them? Absolutely not. You just need to find the first one that gives you a 0, and that will get you off to the races. I know that 2, positive 2, is going to be a 0, so let's do that. I'm going to go ahead and do the work because I need to know what all the coefficients are. So this is going to be 3, -1, -12, and 4. All right, so bring the 3 down. It's going to give me 6, 5. That's going to be 10, -2. This is -4, 0. All right, so this tells me, 1, the 2. Remember, I got that from x minus 2 equals 0, so x equals 2. That's what I'm dividing by. So if I go back in the other direction, I know that my root there is going to be x minus 2. And then the 3, 5, and -2 are going to give me 3x squared minus 5x minus 2. Okay, and then you would factor that. You would use the AC method to do that. And when you factor that, you're going to get x minus 2, and that's going to give you 3x minus 1 and x plus 2. And that's going to give you, again, all this is set equal to 0. So I set each of these equal to 0. And I get x 2 equals 0, 3x minus 1 equals 0, x plus 2 equals 0. And so my critical points are going to be plus or minus 2 and positive 1/3. Okay, so as I said before, because of the extra steps, it's not going to be as straightforward when I do my graph. All right, so I got -2, I got 1/3, and I got 2. All right, so here's what we need to do. We need to pick a number in each section. So something that's less than -2, something between -2 and 1/3, and something between 1/3 and 2, and something greater than 2. We need to pick a number in each section, test it, see if it's positive in that section or negative in that section. And then we will look back at our original problem and see which section results in a true statement. All right, so I'll explain as we go along. All right, I'm going to pick, let's say -3. I'm going to pick 0. I'm going to pick 1. I'm going to pick 3. And if you test each one of those, so you're plugging these back into the original and seeing what it gives you. All right, so let's do that. Okay, so when I plug in -3, it results in a negative number. When I plug in 0, it results in a positive number. When I plug in 1, I get a negative number. And then when I plug in 3, I get a positive number. Now, this entire thing said greater than 0. All right, so what's greater than 0? Positive numbers. So I'm going to shade between -2 and 1/3. And I'm going to shade from 2 up because I want to know what makes it true. Okay. Yeah, it's greater than, so there's no brackets, it's only parentheses. And so my answer here is going to be -2 to 1/3 union 2 to infinity. Now, they could just ask for the graph, they could ask for the interval. All right, you need to be able to get both. So that's how you do that. All right, number 3, we're going back to like we did on number 1. We got, let's see, so we have 4x squared minus 5x minus 6 greater than 0. They don't have a GCF, so I'm going to do the AC method. And so that's going to be x squared minus 5x minus 24, 0, factor, all right, x plus minus 3 and 8 give you 24, and then also give you 5 in the middle, so it's going to be -8 plus 3. All right, I started with 4, so I got to divide by 4. All right, so it's going to be x plus 3/4 and x minus 2. When I get my critical points from here, that's going to be, critical points are going to be -3/4 and 2. Okay, and it's greater than. So I do a number line. I got -3/4 and I got 2. And because it's greater than, it's an OR statement, which means I'm going to shade in opposite directions. Okay, so that's going to be -infinity to -3/4, parentheses, 2 to infinity. Okay. 4, I got 2x squared plus 3x minus 5 less than 0. I'll do the AC method again. All right, so this is going to be x squared plus 3x minus 10 x. All right, so I got plus, minus, let's see, 2 and 5 give me 10, and 3 in the middle, so this will be plus 5 minus 2. All right, I just started with 2, so I got to divide by 2. All right, so this is going to be x plus 5/2, x minus 1. All right, so my critical points are going to be -5/2 and +1. So I'll draw my graph. I got -5/2 and 1. And because it was less than, I'm shading in between. So parentheses, parentheses, shade in between. And so that means my interval is going to be -5/2, comma 1, parentheses on both. All right, so that's polynomial inequalities. Now, when it comes to rational inequalities, you want to get everything to one side. So it needs to be equal to 0. And that's your starting point. And then the rational functions, unlike polynomial and every other inequality, they don't necessarily follow the rules that we've already established. So you always want to check your graph. So you find your critical points and then you check your graph, just like we did on number 2 up there. Okay, so again, getting everything to the same side. Let's see, we're going to get 2x minus 7 over x minus 5 minus 3 less than or equal to 0. All right, once we get everything to the same side, we need to get a single fraction. So we got to find the common denominators. All right, so that's going to be 2x minus 7, x minus 5, minus 3 times x minus 5 over x minus 5. Okay. All right, so that's going to be 2x minus 7 minus 3 x plus 15. You got to distribute the negative over x minus 5. All right, so that's going to give you, on top, that's going to give you negative x plus 8 on top, x minus 5. So how do you find your critical points when you have a fraction like this? Well, if you set the top equal to 0, or if the top is 0, everything's great. You set the top equal to 0, you set the bottom equal to 0. All right, so how do you find critical points if you got a fraction? Well, it's simple. You set the top equal to 0, get an answer. You set the bottom equal to 0, get an answer. So if I plug in, if I set the top equal to 0, I get 8. If I set the bottom equal to 0, I get 5. So those are my critical points. So I draw my graph. All right, I got 5, I got 8. And just like earlier, I need to pick a point on all sides in each section. So let's pick 0, let's pick 6, let's pick 9. And let's see what's what in each section. All right, so it's pretty straightforward. If I plug 0 into this fraction, I get a positive on top and a negative on the bottom. So that's going to be negative. If I plug in 6, I get a positive on top, positive on the bottom. So that's going to be positive. If I plug in 9, I get a negative on top and a positive on the bottom, so that's negative. All right, I want to know, when is it less than 0? Well, that's my negative numbers. So that means I'm going to shade less than 5 and greater than 9. But here's a catch. On top, I can have 0. So I get a bracket on 8 and a shade to the right. But if I equal 5, that's 0 on the bottom and I can't divide by 0. So this one gets a parentheses and a shade to the left. Okay, so my interval here is going to be negative infinity to 5, parentheses, union, bracket, 8 to infinity. Okay, and that's that. That's the process. You get everything to the same side. If it's not already equal to 0, make it equal to 0. Get a single fraction. Clean up the top. Set the top equal to 0. Get a critical point. Set the bottom equal to 0. Get the other critical point. All right, and then plot your points. Test your sections. See which one makes a true statement. You shade the true statements. Your numerator can be equal to 0. Your denominator can't. So that will determine which one gets a bracket, which one gets a parentheses. All right, 6. So we got x minus 2 over x minus 3 plus 3 x minus 3 over x minus 3 greater than or equal to 0. All right, so this is going to be x minus 2 plus 3x minus 9 over x minus 3 greater than or equal to 0. All right, so that's going to give me 4x minus 11 on top, That's going to give me x minus 3 on the bottom. All right, so my critical points are, if I set the top equals 0, I get positive 11 over 4. And if I set the bottom equals 0, I get 3. Okay, so those are my points. I'm drawing my line. I got 11 over 4. 12 over 4 would be 3, so I got 11 over 4 and then 3. All right, so let's pick 0. Let's pick I'll pick 4 over here, and let's do, all right, using my calculator, I found that 23 over 8 is between 11 over 4 and 3. So we'll test each of those and see which one gives me what sign. So if I plug a 0 in to the top, I get a negative. If I plug a 0 into the bottom, I get a negative. A negative over negative is positive. If I plug in 4 on top, I get a positive. On the bottom, I get a positive. So that's that. If I plug in 23 over 8, that's going to be 23 over 2. That's going to be positive on top. And then that's going to be negative on the bottom. And I know that because 23 over 8 is less than 3, and small minus big is always going to be negative. All right, this is greater than 0. The entire thing is greater than 0. So I want to shade where it's positive. I can't let it be 3 because it's going to make the bottom 0, but I can let it be negative. I can let it be 11 over 4. So the 11 over 4 gets a bracket. All right, so I got negative infinity to 11 over 4, bracket, union, parentheses, 3 to infinity. All right. Last one. So I got 4x minus 1 over x minus 6 minus 3 times x minus 6 over x minus 6 greater than 0. All right, so I got 4x minus 1 minus 3x plus 18 all over x minus 6 greater than 0. All right, so 4x minus 3x is x. 18 minus 1 is 17, so I got plus 17, x minus 6 greater than 0. This means my critical points are going to be negative 17 and positive 6. All right, so I got negative 17 and I got 6. All right, so this will be pretty straightforward. Let's do negative 20. Let's do 0. Let's do 10. All right, so if I plug in negative 20, I get a negative on top, a negative on the bottom, so that's going to be positive. If I plug in 0, I get positive on top, negative on the bottom, so that's negative. If I plug 10 on top, I get positive on top, positive on the bottom, so that's going to be positive. This thing is greater than 0, so I want to shade where it's positive. All right, I can let it be 17 or negative 17. So I shade to the left, and negative 17 gets a bracket. I cannot let it be 6 because that would make the bottom 0, and I can't divide by 0, so that gets parentheses, and I shade to the right. All right, so my interval is going to be negative infinity to negative 17, bracket, union, parentheses, 6 to infinity. All right, it was a short lesson, but I hope it made sense. Please reach out if you have any questions, and I'll see you in the next lesson.